Hello, hi everyone. Welcome to Skilled Inspirational Academy. I hope you guys had a very good weekend and you guys have practiced the labs. So this is a free CCNA day 4 class, and these are the topics we are going to discuss today. The very first topic we are going to discuss is identifying the errors and cabling issues. So let's get started. Let me open up my whiteboard and I'll give you an overview about the interface errors and cabling issues. Let's get started. Generally, we all know about this, right? I mean, I think this is a very familiar terminologies now. The routers, switches, this is switch, and I got PCs connected to it. We are working from remote. And if there is some kind of cable issues, how we are going to find from the remote perspective? Because we are not sitting in front of the device to find this, right? We need someone from on-site or whomsoever who help us to find the physical related issue. That's when the commands we use to find exactly what is the error, and it could be a cable issue or it could be a configuration issue. So we are going to discuss about that now. So say for example, in a switch and the PCs, we all know we call this as an interface, right? So every port can be identified with interface IDs. Say for example, I got a fast Ethernet port. Yeah, it's called as fast Ethernet 0/1. What do you mean by that? See, the switch generally it comes with two capabilities. The port density. It's something how many ports this PC should have, right? The PC may have 48 ports or 24 ports. These are the common ports you get in the market. 48 port and 24 port switch. For every port to identify every port has a unique interface ID, or people they call it as a port number. But why this representation 0/1? So it means that this is one box, right? This is 0, and the first port starts with 1, 2, 3, and it goes on till 24. So that's the meaning of this. This is something like a module. There is one module that starts with 0 and I got 24 ports. Say for example, if you have a switch, imagine if you have a switch with 48 ports. This is module 0 and this is module 1. So how the naming convention would be? So it should look like fast Ethernet 0/1, and the second switch starts with fast Ethernet 1/1. Right? This is module 1, port 1. This is module 0, port 1. So this is how you should differentiate the port IDs. This helps a lot when you do a troubleshooting. So for example, if you see something related to a problem with this switch, not this module 1 with the module 2. So imagine this is switch 1 and this is switch 2. And the user has a problem with this port. So how do you find that? So if it is a fast Ethernet 1/1, because this is second switch, module 1 and the first port, the user is connected and he got some problem. This is how, from the remote perspective, you can find the ports. When we look practically, we'll understand better. I'm giving an overview. why this module is about. This is pretty common for all kind of, all kind of switches. The same naming convention will be used. Example here, say if I got 3 switches, right? This is switch 1, this is switch 2, and this is switch 3. So we all know this is first module starts with 0, 1, and 2. So all the ports are fast Ethernet port. Fast Ethernet is just 100 Mbps speed, right? Megabits per second. So these are all the ports on the switch. 1, 2, 3, 4, example. The same way you got port 1, 2, 3 until 24. Same way here, 1, 2, 3 until 24. So how the naming convention would be, since I said this is fast Ethernet interfaces, so it's always start with fast Ethernet. That's a short form of fast Ethernet. The full form is fast Ethernet. The short form of the port is FA, fast Ethernet. 0 module, first switch, first port. Fast Ethernet, 0 module, first switch, second port. Same way, fast Ethernet, 2/1, 2/2. It goes on like this. And here fast Ethernet 1/1, fast Ethernet 1/2. This is how you can find the devices. So how this can be formed? See, when you buy a switch from the market, it is just a 24 port switch, right? It can be a 24 port or 48 port switch. But there is a concept called stacking. So we all know about this virtualization, right? VM. In the same way, we are virtualizing the switches. So for example, you have example, you got 80 users. You want to deploy the switches, but you got 80 users, but the availability I got is just 24 port or 48 port. If I want to fulfill the requirement, I definitely need one more switch, right? So I'm getting a 24 port switch here. Example, I'm saying I'm getting a 24 port switch. So how many 24 port switches I should have here to to provide access to 80 users? I need at least 3, right?
For 80, it should be 4 switches, right?
How much?
For 80 user, it should be 4
Oh,
switches.
sorry. Yeah, 72. We get 72 close to, and we should have 4 switches. Yeah, that's right. So if I got a 24 port switch and I should have 4 switches, right? I got 96 ports. So I can do stacking. What is stacking? Virtually, I can connect the switches like this. So there is one specific port that is used to do this stacking. These are all called as stack ports. This is not an uplink connection, and this port is not, sending any data traffic. This is just sending a management traffic that is related to stacking. Only the management traffic. No other traffic is used. So if I want to send the data traffic up and down, there is one dedicated link that is called uplink connection. This uplink connection carries all your data traffic along with management traffic. And this is not a management traffic related to stacking. This is stacking management traffic. So it could be something, if the port is down, the stack port is down, only the specific information related to stacking will be sent it across this link, the stack ports. The same way you can connect the switches like this. So what happens now from the engineer perspective, all these 4 switches, you can see the status of all the 4 switches and the ports in one single CLI prompt. This is possible. And I'll check, is there any possibility for packet tracer? I have a plan to build up a stack in GNS also, because this needs a physical connection. I'm trying for it, but I'll try to show a lab, but not pretty sure about the stack ports. But this is the, a high level understanding about the stacking. If there is a requirement for more users, if you got about 100 plus users, you can stack up your switches as per the requirement. But this is the concept of stacking. So this stacking ports all management traffic related to stacks. And example, if you see any kind of interface related information, all these ports, we got many ports, the port related information, everything, all the details, whatever you want to see from the physical standpoint or configuration standpoint, you can see the information about all the switches in one CLI. And what is the use of stacking? You can have multiple switches all together and one common control plane. What is control plane? All your routing protocols, whatever routing we are going to discuss about this routing in detail in the upcoming classes. But from the, from the engineer's perspective, as a beginners, I'm telling, all this protocol related information is stored inside the control plane. And all your SSH, telnet, these are all used for what? Remote logging, management. This is called management plane. This is something I would say, to make it very simple. Let me draw a diagram very clearly here. To make it very simple.
Can we connect different models in a stack?
Different model, only the ports you can use. Say, for example, if it is 2960 switch, example, this is S switch, and you got 2960 48 port switch.
Okay.
You can mix both 24 port, but it should be same model. Okay. If it is 2960X, the other switch should be a 2960X, but port can be different. But you cannot connect 3650 switch with 2960. That is not possible. Same switch model, but different ports that can be used. So there are 3 key things we should remember. One is data plane, control plane, and management plane. So as I told you, what is inside the data plane? Data plane is all your data traffic. Your source, destination, what is the IP address used, all your data traffic be isolated one data plane. So imagine like you got one box, right? Your router or switches, whatever it is, logically inside the operating system, they have developed in such a way to keep all this information isolated with each other. So all your data traffic will be controlled by data plane. All your routing protocols and everything will be running inside the control plane, and all your SSH telnet will be running on management plane. This is very important, And definitely this is an interview question. They will ask you what is the difference between data plane, control plane, and management plane, and what is inside control plane and what is inside management plane, what is inside the data plane. So here the focus, the objective of today's class is to focus only on data plane. Yeah, the data, how the data will be sent it across through your ports, right? In the port, you should understand two things. Even in your internet, right? You see two terminologies. One is upload and download. The same way, every port has a capability to send and receive. So receiving is called as RX traffic. Sending is called as transmission traffic, TX. This is your incoming, this is your outgoing packet. So this is helpful for your troubleshooting perspective. Since the first class is about collision errors, you should know about this. Every port has a capability to send and receive, but at the same time. So this is called as full duplex. This is one important question. Is it your switch port is full duplex port? Yes, because it can send and receive traffic simultaneously. Whereas in the hub, it is half duplex device. It can only send or receive at a time. If it is sending, it has to wait until it receives a traffic. That's the reason they call it as a half duplex. So the very best example I gave you in the, some time back, I think in our class, the walkie-talkie is the best example for half duplex. Say you got A and B talking to each other. If A is talking, B should be silent until A finishes conversation. So once he is done, only then B can talk, right? In the same way, half duplex hub works as a half duplex device, but these days nobody is using hub. And one more key thing, I said this, but again, I'm repeating. See, now we got this technology called MDX, auto negotiation. All the ports, switch ports, right? All the switch ports are auto negotiation. But when you connect a router, you should give a command, no shutdown command. Router is not MDX. The switch ports are MDX. What we are doing, but we are going to a corporate office, or maybe you may happen to go for an interview wherever. Example, I'm saying, you just connect your PC. They would have connected the PC. If there is some problem, people say, hey, it could be a problem with your Ethernet connection. Can you unplug and plug it back again to the same port? We are just connecting the wall jack, right? We're connecting our PC in the wall jack. But the port comes up automatically. Is it somebody is doing any configuration in the switches in the backend? No, they cannot keep eye on every single port. Right? When you connect your PC directly to the switch port, it comes up automatically. That's because of auto negotiation. Whereas in the router ports are not auto negotiation. So whatever we discuss here, these are the very key points from physical layer perspective. Very important. Very basics. So you should remember all this. Now let me open up the packet tracer and try to show you the different types of errors, duplex.
MDX stands for auto negotiation, or it has some different abbreviation?
Sorry?
MDX stands for auto negotiation?
Media interfaces, media interface, that's it.
media interface.
Yeah. See, I got a router here. So how it physically looks, I've shown you, right? I think you guys would have practiced in your home. This is how the port looks like. This is called as, mostly they say this is copper port. Okay, two terminology most widely used. One is copper port, or it is Ethernet port. If it is GI capable, let me try to zoom in a little bit. So GE port, right? This is GE. Gigabyte port, 1 Gbps. Fast Ethernet port, 100 Mbps. But Ethernet ports, they are not using 10 Mbps, right? So mostly nowadays the switches are coming with gigabyte ports, very pretty old switches. They are still running on fast Ethernet ports. So this is how exactly the router looks like. This racks, you mount this. I told you in the last class, the same way they connect the devices. You can stack up your devices like this. You can mount your devices. This is the rack. Somewhere they call it as a server room. They manage all these devices physically inside the server room. They have a rack like this and mount all your devices. This is how it looks like. This is more, packet tracer is more, from logical perspective, not physical perspective. So always when you boot up a device, it asks for the initial configuration. You should always give no, because you have to give all the configuration by default one by one. It's always recommended to use no and do your custom configuration. The very first command, always to check the port related information, show IP interface brief, a brief history about the ports. So these are all admin down. Right? If I want to connect a switch, connected a switch. So see, can you see any change? No logs, no activity is still going on, because I have to manually shut and unshut the port, manually manage the port. So what should I do here? If it is connected to a switch, I should first check what is the port it's connected to. GI0/0, right? This is the port. I'm going to copy this, paste, giving no shutdown command. Can you see this? Now the link changed from down to up, changed to up because of this command, no shutdown. So the topics we discussed about the physical layer issues. So this is very useful information you should always consider looking at. See, first, I am working from remote. What I have to check, the first thing is this is physical link, status of the physical link. And this is the protocol related information. It should match the both, and this is logical. This is not physical. So both should be up and running, only then I can send and receive traffic. And from the last 8 seconds, last input I received, the last 8 seconds, I started receiving the traffic. How long it stays? 4 minutes. Sorry, 4 hours. So last clearing is something, if you clear all the information related to this interface, everything will be flushed out. You won't see anything at all. So the key thing here, we have to check errors, input and output. As I told you, you got both RX and TX. RX is receiving and TX is transmission traffic. So I'm not seeing any errors here. And mostly this is CRC error, cyclic redundancy check. So if the CRC is increasing exponentially, definitely it's a problem with the cable. These 3 parameters you should consider if you consider this is a cabling issue. If I come back, see, this is TX load, transmission load, and this is receiving load. This is your upload. This is your download. And do you see any drops? No drops. This is global drops. Okay, this is input Q. Q is something, see, in the same port, if you're trying to access 3 applications, example, sorry for that. Say, for example, the first application is trying to access anything outside. This is egress traffic. This is ingress traffic. To make it very simple, TX, and this is your RX. The same port, you got a switch, same port, you got RX and TX. In the same port, you are sending and receiving, right? RX and TX. So this is, see, this is very important. If it is maximum, it is maxing out to 255. So what is the meaning of that? You are sending a traffic to the maximum. The port is completely utilized in transmitting. And if your RX is maxing out to 255, then your receiving traffic is utilized 100%. Then definitely user will face slowness, right? In the input queue, as I told you, if you're trying to access 3 applications, the priority is given for the first application. And the second application will be queued like this, 1, 2, 3, 4. How many applications you're using? The first, it's something like we are standing in a queue. In the same way, the consideration is given, the priority is given for the first application, and then the second, third, and fourth. And last 5 minutes input and output, 0 bytes, because I didn't send anything so far. So this is how, these are all the very key points to consider and you should be aware of while you do troubleshooting from remote. You should know all this. One minute, sir. Dinesh, I think you're raising your hand. We will have one more Q&A session. You can ask your questions. Yeah. So these are the key points you should consider, as I told you, interface related. I'll try to filter because here it's more information. Let me try this filter works here. Show interface. What is that? I've connected to this port. Pipe include. So what should I check for collision? Yeah. This way you can filter out, is there any collision, zero collisions. So the first topic is we should see the identify interface and cabling issues, collision, errors, duplex mismatch, and speed. So let's now, learn about duplex and speed. It's not showing duplex. Show interface. Include speed. It's not showing speed. It should definitely show speed. Say duplex. Okay, it starts with full duplex. And this is your speed. Example, this is the one of the use case. You got your router, right? The ISP will provide just a box. Imagine this is just a bridge and you got a connection back to ISP. And this is your this is your customer edge router. Customer edge. What is that? Because this is your head end router. Also, they call it as internet router because your internet link is connected to it. So the use case is this particular interface. Sometimes it goes to half duplex mode. And you will see a lot of errors that keeps increasing because in the half duplex, it can only send or receive. It cannot do both simultaneously. It has to wait. So what happens, whatever the packets that's coming from the user PC, that will be dropped. And your input errors will keep increasing here. You have to check your input and output, and you should consider your duplex setting. Let me show you the configuration. I think show run interface command is not supported. Can you see this? Duplex and speed is auto. But when you see in the real devices, the duplex and speed will be configured by the admins. It's not recommended to keep it in auto. What happens, whatever the device in the other end, if you connect, then it starts negotiating. If you give no shutdown command and if you assign the IP address, then it automatically gets connected to it. So what is a key point here? When you buy a new connection, they will give you three details. One is IP address, your public IP address, use the band link, then duplex. They always keep it full duplex. Nobody use half duplex anymore. Then speed. If it is 50 Mbps link, 100 or 1 Gbps. So you should match all the configuration. You should not keep it auto. But when you want to establish your connection, that you have a connection to your ISP, you have to assign an IP address, then keep these two values default. So once you get a connection and you can, once this is connected, the WAN link, we all aware of, WAN is not something like a LAN connection. Mostly two IP address will be used. Today's class, I think if we have time, we will cover the addressing, IP addressing. If not, in the upcoming classes, we'll get a clear idea about the range of IP address that should be used in the public and private. So now for understanding, I'm saying always WAN connection will not exceed more than two IPs. One in the customer end and the other IP is on provider end. They call it as CE and PE. These are all terminologies they use. What is the status of your CE device? So you can ask a question back, what is the status of your PE device? You can ask a question, okay, what are all the configuration you did on your end? What is the speed? What is the duplex? What is the network range you used? Because based on that, I can make my connection back, right? They will provide all these three details with your public IP address for your order. If you order a WAN link, you will get all these three details and you should configure here. But as I told you, first assign an IP address, keep the speed and duplex auto, because whatever the speed and duplex they have configured on the remote end, the provider end, actually your customer router will negotiate, auto negotiation will happen and the link come up. Then you can actually find out how. If you give a command, show interface command, it will exactly show you, the duplex, in which duplex it's negotiating. It says half duplex or full duplex and your speed. And by looking at that, you can make your configuration. Based on that, you can do your configuration. This is the use case, a very useful use case, I would say. So what is the next thing? Speed. We have discussed about speed. Okay, duplex mismatch. We'll do in simple lab for it to do duplex mismatch. Let me try to do CDP neighbor. So let me maximize this. So this is my local interface. So everybody might be aware about this now. We had a detailed class about this ports, local interface, remote port. So I'm going to check show run. And what is a port? Fast Ethernet 0/1. So nothing showing inside. Packet tracer. Show run interface. Okay, this command is not working. Let me try to change the duplex value. Interface fast Ethernet 0/1 duplex. Let me make it as half duplex. Can you see this? The port status changed to down to up because I changed the status. So you'll have a physical disconnection here. So what about the port? Can you see this? This port is negotiating to half duplex. Whenever you see an amber light, it means it's negotiating. On the other end, it's not up and running. Now can you see it turned green? So let me check. Let me try to send some traffic back. So, okay, show interfaces is showing me. I'm interested on half duplex. Okay, can you see this? This is changed to half duplex manually. And I'm trying to see, I can see any drops. Okay, let me do one more thing here. Let me assign an IP address interface VLAN 1 default VLAN IP address 10.0.0.1 default subnet mask value and no shutdown. The state is up because this is a default VLAN. It's been from the box. I can see this right from the box. This is by default. I got this VLAN 1. That's the reason I didn't create an L2 VLAN. It's by default. When you have your Cisco boxes comes by default. All the other custom VLANs you have to create. So I have assigned an IP address, and what should I do here? Here I have to go back to the router. And so what support? Can I say in the both end? We see this log. They call this as a syslog information, system logs, log files. You can give show logging command, and you can see all your logs. So this is logging information. If it exceeds 4096 bytes, then it will be overwritten. Here they have configured, see that this is levels. So in the upcoming classes, I'll explain about the different level of logs and what is important, what is to consider. All this port up and down status will be on level 5. You can see this, right? Level 5 logs. Okay, for now, let's go and assign an IP address for this port. IP address 10.0.0.2 55.0.0.0. Okay, no IP address. I'll tell you about this. No shutdown first. Is it the same? I can always give to verify what is the connected device. It's local device, local interface, and this is the port it's connected to. Can you see this? This is fast Ethernet port and this is gigabyte port, but still it negotiates. Because the speed and duplex, we have set the speed and duplex by default, so auto. So even though the remote, the local interface is capable of 1000 Mbps, but the remote port is capable of just receiving 100 Mbps, right? So even though it sends a packet, it will queue and receive the traffic based on the configuration. Here, it's a maximum capacity of this link is 100 Mbps. This is 1 Gbps, but still it works because of speed and duplex. Both are same. Here the speed is different, right? This is 1 Gbps and this is 100 Mbps, but still this works because we kept speed or 2. Let's check that from the router's perspective. What is it actually receiving here? Can you see this? This is 100 Mbps, but this is gigabyte Ethernet port. But since the remote end is configured for auto, this is negotiating to 100 Mbps because it cannot send more than that, right? This is capable, but the switch cannot receive the traffic with 100 Mbps link. So this is speed and duplex auto, the use of speed and duplex auto. If you consider all these tiny details, this helps very much for your troubleshooting. This is the first layer, physical layer. If you have more details like this, as I told you, it's very, it's very useful for you to troubleshoot and figure out the issues. That's it. And the duplex is half duplex because there we changed, right, to half duplex. This is duplex mismatches, and I want to assign an IP address and to check if I see any drops because of half duplex. So IP interface brief, and this port is up, protocol is up, and I didn't assign an IP address, unassigned, right? So I have to assign an IP address. How to do that? Interface gigabyte 0/0. Sorry, interface gigabyte 0/0.1. Sub interface, logical interface. I'll tell you what is the logical interface. And encapsulation dot 1q1. Here I can assign an IP address 10.0.0.2.2.3.0.0.0. And let me check. I can show CDP neighbor. See, show CDP neighbor will give you this information. What all the information you will get? Sorry for that. So what all the information you will get from here? So you will get the local interface detail, the capability of this appliance. This is switch, right? ES stands for switch. And this is the model of the device. This is 2960. And this is a remote port ID. We discussed this in the before classes, right? So this is a connection back. Local interface gigabyte 0/0. It's connected back to fast Ethernet 0/1. But you have one more command. Show CDP neighbor detail. Show CDP neighbor detail. Can I see this? Now I can see the IP address, whereas in the show CDP neighbor, I can see only the port information, capabilities, platform, and the remote port address. But here I get a detailed information. Can you see this? This is 2960 switch, and the capability is a switch, and the local interface is gigabyte 0/0/0, and the outgoing port, the remote port is fast Ethernet 0/1, and it gives the iOS version of the switch. This is 2960 switch, and LAN base 9, and the version is 15.02. And the duplex is full. See, from this you can figure out CDP got many versions. Okay, CDP 1, 2, and 3. I think I don't know. I have to check about the upcoming version, the new version of CDP. But this is CDP version 2, and every version it has own features that's built in. So see, in CDP version 2, I see what are the details. I see the iOS version. I can see the capabilities of the switch, right? And what else? I got iOS information, remote port ID, local interface, and along with an IP address. This is very important because if you want to log in a device, because you cannot remember all the IP address that's configured in the remote end, right? Say, for example, you got a device. You are sitting in this device, you are accessing this device. For example, you got 3 devices connected, 3 switches connected. Imagine. So you will get to know the IP address of all the devices. From this box using show CDP neighbor detail command. So the output you will get it, but what you want, you should focus on that. What are the information I'm getting for every single command? That's the key here. So I get all this information, IP details and iOS version and all that. For your information, I'm explaining all this. That's it. And what else? I can see the IP address of this device, and I'll try to ping this device. 10:01. Okay, can I say this? I can ping this device. See why I'm getting a drops here. So every time when it sends the very first time, it's something similar to your system cache. This is the very first time this router is trying to ping this switch. So what the ping command does, it will send an ICMP request, 4 ICMP packets, okay, 4 ICMP request, and it will wait for 4 ICMP response. There are more. I mean, somebody, they say it's echo request and echo reply. Goes in and comes back, vice versa. In the pieces, you can actually see that 4 continuous pings. You can see 4 ICMP probes. So for the very first time, it's trying to reach, right? So what it will do, the router, it will check in the routing table. Hey, where is this 10.0.0.1? Okay, the 10 network is directly connected network. I have to go check inside the routing table and I have to ping. But once it learns the ARP, this is the ARP cache, right? I got this detail, so I don't want to check for the second time. I'll go do a ping, instant, fast. That's because it has a value saved inside the cache. But for the very first time, it takes some time to check inside the routing table. Okay, I got this network and I can reach here. Because it has to go through the OR process, right? First time, it doesn't know about this details. So that's the reason it has taken time. So now I got a connection. So let's see if I see any drops. I can try to, do a continuous ping. Ping 10:01. Repeat. I think this command is not supported anymore. Actually, there is in the real devices. We can do. I'll show you that the command is continuous ping. If you want to do in the real devices, it's something ping destination IP followed by repeat 100 times. Every time 4 packets. ICMP request. So I'll try to do this in GNS lab, not today. Tomorrow I'll try to build the same lab in EVNG. There you have a capability of running continuous ping. So now let me see if I can see any errors on this. Let me see errors, no input errors, no output errors. Duplex is half, fine, but no total drops. So I'll try to simulate this in lab. Even if it is a physical link issue, we see drops. But I thought maybe if it is in a half duplex, maybe it would be in the input queue, and we might see drops here. You see in the input queue, since it's in a half duplex, but we are generating very less traffic here. Maybe I'll try to generate more traffic and find if I see any drops here. But in the real world, if you make it as a half duplex, then it's really a performance issue. You should not set that to half duplex. Unless it should be full duplex, because all these are all full duplex capability ports. This is not hubs. It's used the same first in, first out queuing strategy. So what is the next topic we got? On-premises and cloud. Let me open a whiteboard, that would be better. Okay. What is on-premises? This is very important. Why they call this as a data center? So you can imagine your home router, you got your PC, right? Your home router, you got your PC, and you got your laptops, your mobile, everything, all this data. If you're saving something, example, if you got a server, like a storage server for your PC, maybe your PC, you're trying to access, all your information will be saved here. In the same way, for enterprise, say for example, this is google.com. This is a data center of Google. So we got our email server. Say where we got all our user database. This is managed and saved inside this email server. Yeah, all this information will be saved inside the email server. You got maybe your file server, where all your Google Drive information will be saved inside the file server, example, all in one place, right? They call this is data center. The name you can figure out. This is data center. All your data related to your user database, your files, and everything will be saved inside the server. So now apparently you guys would understand where switch comes in the middle, right? In all that, definitely it should be connected in one switch. And you got the PCs. See, there is in the upcoming technology, and now they are using VMware also. You can virtualize your PC. It's not like it should always have a server in the physical form. You got your VMware and you got multiple instance, right? You got your VMware. I'll show you how it looks. Maybe you guys would have seen that, but this is only for my PC. But generally the VMware, it looks like this, right? So I got different, this is something, it's a different operating system. So this is, I got my Palo Alto device and I got my EVNG. There's all this in one single box. I can virtualize. In the same way, they can also have a very big VM workstation. They have multiple servers running inside, right? So all in one place, all your file server, your email server, your database server, SQL database server, all in one place. That's data center. So this is the conventional design so far. So what is the problem? If the user want to access a data, say for example, you are at home, working from home, right? If you want to access your email server, you have to connect back to, this is internet connection. You should have a VPN connection. That's your tunnel traffic comes back to this data center, and you should access your email server. So now this is the conventional design, but now the world, they transformed into a different design. This is a conventional approach, but how the database are maintained now? See, you got, okay, let me make it as this is an internet. You got your PC. This is one big internet cloud, right? And they got a device connected here. Example, your ABC company, ABC domain, or your company name, example. Everything is hosted in the internet. I don't want to rely on the data center conventional design to save all my data. It's hosted in the internet. All I need is I have a broadband connection that's connected back to the internet. I can access my application. You might be heard about this Office 365, your Microsoft, your Gmail. Everything is hosted on the internet, right? So all you have to have is a broadband connection. You're connected to internet, that's it, boom. You're connected back to your Office 365, your Gmail account, whatever available in the internet, because they hosted in the internet. So let's come back to the conventional design. Say if your company is not hosting or not hosted your Office 365 application, what you have to do? I'll tell you. It has to take a longest path ever. You got your PC. You are connected to internet cloud. It has to go back to the data center. So inside the data center, you got an email server. And you want to access all the way back to your email server. It may be a 2-hop away here if it is in the cloud. Hosted your Office 365, it is just 1 hop away. Example, it will definitely take many hops. For example, I'm saying because you got many devices in the middle, right? It is not that you are connected to Office 365 in one gem. Definitely you got devices, routers running your BGP. We'll learn about that in detail in the upcoming classes, but just for example, I'm saying they're running BGP, they have an interconnect, and they have a connection back. Say, for example, if it is taking a 4 hops, example, I'm saying it will definitely take 8 to 9 hops, and 30 hops is a maximum. If your traffic exceeds 30 hops, your connection will be dropped. So in the 4 hops, I can reach my Office 365 from ABC company. It has to take, all the way back 6 hops or 7 hops back to my data center, because it has to go to the internet. Then again, it has to talk to all the way back to the connected devices, and it should connect it to my internet router in the data center. Then it has to come back and should access the email server. So the latency is reduced. On the fly, if you have your laptop, you can access these applications. So this is the difference between the data center deployment and cloud deployment. So this is how people are calling it as cloud, transforming more into cloud. Everything hosted in the internet. All you have to have is your browser. Just type application or whatever the desired services, boom, it opens up in your laptop. That's how it's transformed now. So let me show you the diagram. I think it would be helpful for you to visualize better. Can you see this? All your, as I told you, the AWS, the Azure, the Google Cloud, everything is hosted in the internet. So if you are sitting from your home with your PC, you're also connected to internet. Same thing, right? So imagine this is one public cloud. So called as internet cloud. Access everything. If you search for the terminology, what is internet? Everything is connected. But your data center is connected. This connection is happening only for your local servers, right? And users. Not everything is connected inside the data center. If the data center is connected back to the internet, you can access anyone, right? You can sit from your home and you can access your office applications. Your applications related to your company, and you from the same place you can access Microsoft Azure that's hosted on the internet. Everything, one to everyone. 1 to 1. See, if customer is sitting with the data center, she should access this. And if you want to access something hosted on the internet, he has to go to data center. From the data center, he got an internet router. From there, he can access the resources that's hosted on the cloud. So now everybody is transforming to cloud. So if you have everything on the cloud, you can access it directly. So that's the key difference between data center and on-premises. I think it's deleted. It's deleting the whole thing. So this is a key example between the data center and cloud. Okay, guys, I think today we can cover only three topics, sorry. We have checked with the lab. We found out how we can find the duplex issues, cable issues, collision errors, mismatch, speed, and we have seen in detail about what is on-premises and cloud. In the upcoming classes, maybe tomorrow we can focus on IP addressing first, and then followed by TCP and UDP, and what is the difference between OSI and TCP IP model. Thanks everyone. I hope everybody enjoyed today's class. Do practice the same in your home. Have packet tracer installed, check, and we may have a Q&A session on Wednesday. You can ask all your questions on Wednesday. I will try to answer your questions and help you out with your lab. And if you have any problem with your understanding, I will try to explain. Thanks so much, guys. Yeah, we will catch up tomorrow. Have a great day then.
Thank you, sir. Tomorrow we will have labs on Eve.
Sorry, tomorrow?
We will be performing the labs on Eve, EVNG.
Labs on EVNG, yes, sir. I am checking for it. Actually, my EVNG crashed. That's a problem. I'm trying to fix that. So I'll try to set up a lab tomorrow. I'll try my best.
Okay, sir. Thank you.
Thank you, sir.
Okay. Sure. Okay, then we'll catch up tomorrow.
Thank you, sir.
Have a good day. Bye, everyone. Yeah, bye.
Thank you. Bye, sir.